Every single day, there's this hidden world operating right beneath our feet. A world we all contribute to, but almost never see. So today, we're going to pull back the curtain on the secret life of sewers and the incredible journey of our wastewater. I mean, think about it. After you flush the toilet, do a load of laundry, or wash the dishes, that water just vanishes down a drain. But its journey? Oh, it's just getting started. Because designing a system that can handle all of that from an entire city is like trying to solve a massive urban mystery. And the engineers, they're the detectives on the case.
Okay, so the first and most obvious source of all this wastewater is, of course, us. It's our homes. What's pretty amazing is that our daily habits create a flow that's surprisingly predictable. Just take a look at this breakdown. Toilet flushing and bathing. Just those two things make up more than half of all the wastewater that leaves our homes.
On average, about 80% of the water that gets piped into our homes goes right back into the system as wastewater. Engineers actually have a term for this. They call it the return factor.
Now, if engineers only designed for this predictable flow from our houses, our cities would be in huge trouble. Why? Because there are other, way more secretive contributors lurking in the system. So what are these secret guests that engineers have to account for? What else is getting into those pipes?
Well, beyond our homes, you've got waste from all kinds of industries. And then, crucially, there's water that was never, ever supposed to be in the sewer pipes in the first place.
Unlike the pretty consistent waste that comes from our homes, industrial discharge is a total wild card. Seriously, it can be anything from corrosive chemicals to liquids at super high temperatures that can literally damage the pipes and the whole infrastructure.
You'd think it's the factories, right? But it's not. The biggest threat is actually the weather and the simple fact that our infrastructure isn't perfect.
Yep, all that rainwater and groundwater that sneaks into the system can absolutely crash the party. Engineers call it infiltration and inflow, and this stuff can overwhelm the entire network.
So, infiltration. Think of that as a slow, steady leak from the ground into the pipes through tiny cracks. But inflow? Whoa! That's like opening a fire hydrant directly into the sewer every single time it storms.
And this isn't just some theory. One engineering report found that the flow in a city's sewer system actually tripled during monsoon season, not from more people flushing, but purely from inflow overwhelming the pipes. When that happens, you've got a massive problem.
So this is the really crucial point. Engineers have to plan for these absolute worst-case scenarios right from the very beginning.
Well, you have to make a really fundamental choice about how you're going to collect and transport all that water.
And engineers basically have two main options. They can build a combined system which uses one giant pipe for everything, sewage, industrial waste, and all that stormwater, or they can build a separate system which uses two pipes, one just for sewage and another one just for rainwater. To avoid that nightmare scenario of raw sewage flooding the streets during a heavy storm, pretty much all new projects choose the more resilient, separate system. Yeah, it might cost more up front, but it's way safer.
So when it's time to actually design a sewer system that's going to work, it all comes down to getting one final calculation exactly right.
And this is it. This is the single most important number in the entire process. It's known as the design flow. It's really like a recipe when you think about it. You start with your predictable base ingredient from homes. Then you add in the variable ingredients from industry. And then, and this is the critical part, you have to add in those party crashers, the infiltration and inflow, to know your total worst-case volume.
Because leaving even one of those components out of the calculation, that's how you get flooded streets, overloaded treatment plants, and a public health disaster.
It's this hidden, high-stakes math happening beneath our feet every single day, and getting it right is what keeps our modern world running.